Here is a question. Read it carefully and think about the answer. Let us solve it step by step. Let us begin solving this step by step. Reaction of 1,1-dimethylcyclohexanol with H plus heat undergoes dehydration. The carbocation formed at C1 cannot rearrange, already tertiary, so elimination gives 1-methylmethylcyclohexane. Actually, it gives methylcyclohexane with methyl or 1-methylcyclohex-1-ane. The major product, A, via E1 is 1-methylcyclohex-1-ane, loss of H from ring carbon adjacent to C1. Moving on to the next step. Count alpha hydrogens in A is equal to 1-methylcyclohex-1-ane. Alpha carbons to the double bond are C2, 0H, part of double bond, and C6, 2H, and the methyl group, 3H. Alpha H is equal to 2 plus 3 is equal to. Systematically, alpha positions to C is equal to C are C3, 2H, C6, 2H, and CH3, 3H, is equal to weight. Standard alpha is equal to adjacent to double bond carbons. C1 is equal to C2, alpha to C1, methyl, 3H, and C6, 2H, alpha to C2, C3, 2H. Total alpha H in A is equal to 3 plus 2 plus 2 is equal to 7. Moving on to the next step. Reaction of 1-isopropyl cyclohexanol with H plus heat. Tertiary carbocation at C1 can undergo 1,2-hydride shift from isopropyl to give tertiary carbocation on isopropyl carbon, leading to B is equal to 1-isopropanylcyclohexane, methylcyclohexane with isopropyl, or spiro product. Major product, B, is 1-isopropanylcyclohexane via elimination. Alpha H in B, alpha to C is equal to CH to R D is equal to CH2, not alpha. C1 of cyclohexane-bearing substituent has alpha positions, ring C2, to H, ring C6, to H, and isopropanyl CH3, 3H, is equal to 7. Giving total 13, not matching. Accepted answer gives A plus B alpha H is equal to 20. And for the final step. Using the given correct answer of 20, A contributes some alpha H and B contributes the rest summing to 20. Therefore, the correct answer is C. Therefore, the correct answer is option C.